Hello everyone, today we are going to review a concept that we spent a lot of time on before spring break, and that is factoring polynomial expressions. And I want to emphasize expressions so that when you look at the problems that we are practicing on our review, on our weekly review here, you'll see that we have no equal signs, so we have no equations here, and that's going to be a big difference between the expressions that we've spent so many weeks on factoring before spring break versus the equations that we will start to look at this week. So for right now, let's just go through and practice factoring these 8 polynomial expressions. If you want to right now, pause the video and write down the 8 problems, or you can just go through and write the problems as I do when I go through each of those. Totally your call, so if you want to pause it, go ahead and pause it now. So one thing that we learned, or one thing that we used, was just a flowchart to help us remember our steps in factoring. And we wrote this over and over again in the 4 to 5 weeks before spring break. This is a very scaled down version of it. By now, this is probably all we need to help us remember that when we go to factor, we always look for the greatest common factor first. It doesn't matter how many terms it has, that's what we look for first. And if there is one, we factor it out. If there isn't one, what we look at next is how many terms am I dealing with? Do I have 2 terms? Do I have 3 terms? Do I have 4 terms? And that tells me how I'm going to approach the next step in factoring. If I happen to have a binomial with 2 terms, then the pattern that we've talked over and over again about is a difference of 2 perfect squares, which we said looks like a perfect square minus a perfect square. So something like x squared minus 49. If we looked and inspected and saw that we had a trinomial, 3 terms, we would take and then look at using the box method. And we talked about 2 different types of trinomials, one where the a value was equal to 1 and one where the a value isn't equal to 1. And then our last one here that we looked at is if we had 4 terms, we would do grouping. And you're going to notice that when we go to review today, that we focus just on the binomial and the trinomial. And that is because the problems that we have coming up this week focus on these 2 types of factoring. But I did want us to remember that we have that one where it was 4 terms, and we take and group them into 2 groups of 2 terms, and then take out our greatest common factors. Okay, so let's just do some practice problems now. All right, so our first one here is 2x to the 5th minus 4x to the 3rd. And the first thing I'm thinking in my mind is I need to look for a greatest common factor. And if I look at my constants or my coefficients, I have a 2 and a 4. So the greatest common factor here is going to be a 2. But I also have to look at my variables. I have an x to the 5th and I have an x to the 3rd. So if I think about 3, 4, 5 x's there and 3 here, there would be x to the 3rd in common. So that makes my GCF a 2x to the 3rd. And so that means that when I come over here to do the problem, I'm going to take and factor out, divide out a 2x to the 3rd. And so that, remember, both of these terms get divided by that GCF, and then the GCF always gets written out front here. Okay, so now I'm going to look at this one. My 2's are going to cancel out to a 1, and that's going to give me x to the 5th over x to the 3rd, which would be x to the 2nd. Negative 4 divided by 2 will be a negative 2, and then my x to the 3rds would cancel out. Would become 1. So if I'm looking here at my answer now, I see that I have a GCF of 2x to the third. Remember that I always have to look at what is left inside of the parentheses to see if it can factor further. And what's left inside the parentheses is x squared minus 2. And remember that if I have a binomial, if I have two terms, the factor that the pattern that I know for that is a difference of two perfect squares. And what I'm looking for is a perfect square minus a perfect square. And what I have in the parentheses right now is x squared minus 2. So what I see here is that this is a perfect square, this is a minus sign, this is not a perfect square. So this cannot factor any further, and therefore this is my answer. All right, looking at number 2, first thing I think in my mind is there a greatest common factor between 2, 13, and 21? And there is not, so I don't have to worry about a greatest common factor. I also notice that there is an x squared term, an x term, and then this doesn't have a term, so I know that there's not going to be a variable that is the greatest common factor. What I do notice is that this is a ax squared plus bx plus c, and so that tells me that I'm going to start by making a box. And I'm going to lock in what I know. What I know is that if this is 2x squared, that has to come from 2x times x. And remember that I could have put the 2x here and the x here. I chose where to put those. It doesn't matter as we go through the problem. Now, here's what else I know. I know that this is a positive 21, okay? And so I know that I get a positive by multiplying two positives or two negatives together. And so when I look right here, I can see that I have a negative 13, and that tells me that I'm looking for factors that are negative that multiply to a positive 21. And that when they combine to a negative 13. Okay, so I'm going to start by listing the factors here. So 21, negative 1 times a negative 21, a negative 3 times a negative 7, and I think that is it for factors of 21. Now, I have to then select a factor to start with. And remember that this is trial and error and persevering through the problem. So when I look at this, I'm going to say that 21, that I wouldn't use this one to start with, because I only need to make a negative 13. And so I'm going to think that number is a little too high. Now, I may be wrong, but I'll take a look at it and see. I'm going to start with the negative 3 and the negative 7. And I'm going to place them knowing that I might have to change the location. So if I put the negative 3 here and the negative 7 here, when I multiply negative 3 times 2x, then that is going to give me a negative 2x. And when I multiply the x times a negative 7, then that is going to give me a negative 7x. And then what I noticed is that I was lucky and hit it first time, and that negative 6x and negative 7x will combine to make that negative 13x. So when I look here, I have a 2x squared, which matches my 2x squared. I have a negative 13x, which matches that middle term, and then a positive 21, which is right there. And so now I need to write my final answer, which is going to be x minus 3 times 2x minus 7. Okay, in problem number 3, I look at it, can automatically tell that I don't have a GCF. And what I see is two terms. So I think, is this a difference of two perfect squares? So the pattern I'm looking for is this a perfect square minus a perfect square? And so when I look at what I have, 9x squared is a perfect square. There is a minus sign. There is a perfect square. 1 times 1 is a perfect square. So I can, if I see this pattern, I can immediately go to the answer and say, well, 9x squared is 3x times 3x. And a 1 is 1 times 1. And then I know I need to make this a negative 1 in here. And how I make that a negative 1 is by multiplying a positive and a negative. Now, if you see that pattern, you can do that and go straight to your answer. Remember that if you don't see the pattern, you can always go and use the box, which is how we started with these problems. But we really want to concentrate on now if we see that we have a binomial, to check to see if it is a difference of two perfect squares, and then use that pattern. All right, number 4, I look for a GCF. I see a 1, a 3, and a 10. There's no GCF there. So I'm going to look and say that it has 3 terms. It is an ax squared plus bx plus c type, which I know means I'm going to use my box. Now, some people are getting to the point that they don't need the box. They can kind of picture the box in their head and do those manipulations, and that's perfectly fine. If you're there, great, go ahead and do that. Okay, so we're looking at what I know first. I know this is x squared, lock it in, x times x. Okay. What do I know over here? This is a negative 10. When I see a negative constant value, that negative c, then that tells me I know that I need to have one positive factor and one negative factor. Okay, so when I'm looking at the factors in 10, I'm either talking about negative 1 and 10, or 1 and negative 10, negative 2 and 3, or 3, excuse me, let me back up here, negative 2 and 5, or 5 and negative 2. Now, I select those, out of those 4 choices, I'm going to select the correct pair by looking at this middle term right here. If I have to make a negative 3, then what I know that I need to select are the 2 terms that when I multiply to a negative 10, that I add these to a negative 3. So when I add, that would make a 9. When I add, this would make a negative 9. When I add here, this will make a positive 3. When I add here, this will make a negative 3. And so that tells me that that is going to be the correct choice, and I'm going to put in a negative 5 and a positive 2. And so that when I go to multiply here, x times a negative 5 will become a negative 5x. And then negative 2 times x will become a positive 2x. And then I can check and see, well, this is x squared. Add these together, that is a negative 3x. And then negative 10 is our constant. So that tells me that our correct answer is going to be x minus 5 times x plus 2. All right, looking at number 5, I see a 2, a 3, and a 1, and I know that there is not a greatest common factor. I look at it and see 3 terms, so I know this is an ax squared plus bx plus c. I also notice that this a value right here is a 2 and not 1, so this is going to be one that is maybe I'm going to have to persevere through and make sure that I get the signs correct. So I'm going to take and draw my box. It's a 3-term. It's a binomial. So what do I know? I know for sure this is 2x squared. I know that this has to be a 2x times x. What else do I know? Well, I know this is a positive 1. And here's where I kind of really luck out with this problem. Positive 1 can only be 1 times 1 or negative 1 times negative 1. And since this is a plus there, I know that both of my signs are going to have to be positive. So I'm going to take and put in a plus 1 and a plus 1. And if I go to multiply here, 2x times a positive 1 will be a positive 2x. And if I multiply here, x times 1 is going to give me a positive 1x. Now if I go to combine and check, here's my 2x squared, here's my 3x, and here's my 1. So I know I have the correct 2 factors, which are x plus 1 and 2x plus 1. All right, here's number 7. As soon as I look at number 7, I see 2 and 20, and I think greatest common factor. So looking at this one, my GCF between 2 and 20 is going to be 2. But then I also notice that there is an x squared and an x, and so I know my GCF is going to be 2x. And so if I look at this, I'm going to divide by 2x, divide by 2x. And this is going to give me an x. 20 divided by 2 is going to give me a 10. The x's will cancel out. And then remember, I'm always going to check myself and look inside this parenthesis right here and see, can it factor any further? And it's a binomial. I should immediately know it can't factor any further because the only binomial pattern I have is a perfect square minus a perfect square, which I don't see. And so then this becomes my final answer. All right, so 3x squared minus x minus 4 does not have a greatest common factor. It is 3 terms, so it's a quadratic trinomial. So I'm going to take and draw the box. I'm going to lock in what I know, which is that 3x squared is 3x times x. And then if I go to what I know from here, that this negative 4 is negative 4. We then know that this has to be either negative 1 times 4, or 1 times a negative 4, or 2 times a negative 2. And so now this is one where we have a ax squared plus bx plus c, and we notice that the a here is not 1, and so we know that we have to make sure that we're making certain that this 3 affects our answer, and so we might have to take and try a few things to be able to get to the answer here. So if you just want to start with trying the first combination here, we could say that this is 3x minus 1 and x plus 4. And if we multiply, that would give us a 12x and a negative 1x. And then when I go to combine them, that would give me an 11, and that would not work. Now, you may immediately move on to a different combination, or you might say, well, I'm going to try the 1 here and the 4 here and move things around. Remember that how you go through this trial and error really depends on how you see what you see in the problem. The more you see those combinations, the faster you're going to be able to get to the answer. So let's say that the next thing that I'm going to try is I'm going to try a negative 4 and a positive 1. And so that will give me, when I multiply this times this, that's a negative 4x, and I multiply this times this, that's a 3x. And so I could see now that here's my 3x squared right there. And then when I combine this, this is my negative 1x, and then this is negative 4. And so then that would tell me, hey, I found the correct combinations, and those combinations are x plus 1 and 3x minus 4.